In our previous video on HSRP configuration, we took a look at the show standby brief command, which showed us some great information about any HSRP groups we had configured. We could see, for example, who was the active router, who was the standby router, what was the virtual IP address, is the preempt option set, what is the HSRP group number, what interface is participating in that group. However, we can get even more information by not giving the brief option. What if I just say show standby? And this is based on the configuration that we performed in the last video, and you'll see that we get some additional information. For example, we configured the interface tracking option in the last video, and we see that here. We see that we're tracking interface serial 1/0. It's currently up, but if it were not up, we're going to decrement the HSRP priority by 20. And something else that's very interesting is the MAC address. Think about this from the perspective of the PC. The PC is configured with a default gateway, but in addition to that, the PC has performed an ARP to look up the MAC address that corresponds to that default gateway's IP address. And when we fail over from one router to the other, not only do we need to have that other router start servicing the layer 3 IP address, but also the corresponding layer 2 MAC address. And even though we could configure that manually, HSRP is going to automatically generate for us a MAC address. Here's the way the format breaks down. The first half of a MAC address is one of Cisco's vendor codes. The next 4 hexadecimal digits in the MAC address, Cisco has designated these digits to indicate that we're using HSRP version 1. And the last 2 hexadecimal digits represent the HSRP group number, but in hex. Do you remember what our number was? It was 10 in decimal. What is 10 in decimal? It's an A in hex. Remember, in hex we count 0 through 9, and then instead of saying 10, we say A. Instead of saying 11, we say B. 12 is C, 13 is D, 14 is E, and 15 is F. And if we go to 16, then suddenly we put a 1 in this column, and then we go back to 0 here. But in this case, we have a group number of 10 in decimal, so that's going to be an A in hex. That's where this A comes from. But if we're troubleshooting HSRP, it might be helpful to see debug output. That gives us nearly real-time information about what's going on in the HSRP negotiation between our routers. To do this, we can go to router R2 and let's do a debug standby. And there are several things that we could debug, but I'm going to use terse. This is going to debug errors and events and packets all with one command. We'll say debug standby terse, and then let's go to router R1 and we'll go into interface fast Ethernet 0/0 and let's shut it down. Then let's go to R2 and see what it sees happening as we start to transition from the standby router to the active router. Looks like we've transitioned. I'll do a U-all to turn off our debugging, and let's see what this is telling us. This tells us that our hold time timer has expired on R1, and we are now the active router, even though it used to be 10.1.1.2, which is R1. Here we see that we transitioned from standby to active, and we see we've added to our ARP cache the MAC address for the virtual IP address. And here it is, 5 zeros and a C, a Cisco vendor code, 07AC, which indicates HSRP version 1, and then 0A, indicating HSRP group 10. Let's go back and fix router R1. I'll do a no shutdown. And what I'd like to do now is to set up HSRP version 2. Cisco recommends that we use HSRP version 2 if we want our hello time to be anything less than a second. So if we want to speed things up, we should set our HSRP version to version 2. Then we can set a much smaller hello interval and hold time timer. Here's how we do that. We say standby version 2. And now we can set our timers. Let's say standby. Oh, and notice what just happened on screen. It says that I have a duplicate IP address. Because I'm running HSRP version 2 on this router and HSRP version 1 on router R2, it's detecting a duplicate IP address. That'll be fixed once we set this up on router R2. But for now, let's say for standby group or HSRP group 10, we want to set our timers to something less than 1 second. I'll say timers millisecond, and we'll set it to, let's say, 100 milliseconds for our hello interval. And for our hold time timer, let's set it to at least 3 times that. It has to be at least 3 times. I'll set it to 300 milliseconds. Now let's go do the same thing on router R2. That'll get rid of our duplicate IP address issue. Let's go to router R2 And let's go into interface fast Ethernet 0/0, and we'll say standby version 2, and we'll say standby 10 timers millisecond, 100 for the hello interval, and 300 for the hold time timer. And once we do this, now we should be up and running with HSRP version 2. Let's do a show standby brief. And just to make sure, yes, indeed, we are in standby, and we are recognizing router R1 as the active router. So now we should have much faster convergence times if router R1 were to go down. Let's try it out. Let's go back to our PC, and let's once again do that ping command. Let's do a ping to IP address 1.1.1.1, and we'll do lots of repeats. Let's get a stream of pings going. Let's go to R1. And we'll go into interface fast Ethernet 0/0. We'll do a shutdown and very quickly jump back to the PC. And let's see if we lose anything. We lost several packets before, but look at this. We just lost one ping packet. We really sped things up by using HSRP version 2. I'll bring this interface back up. I'll do a no shutdown. And I want to show you that the MAC address has a slightly different format with HSRP version 2. Let's do a show standby command, and this time notice it says that this is a version 2 MAC address. We still begin with the Cisco vendor code of 5 zeros and a C, but now instead of saying the next 4 hexadecimal digits indicate an HSRP version 1 MAC address, we're saying that the next 3 hexadecimal digits, 9FF, represent an HSRP version 2 MAC address. And this gives us 3 hexadecimal digits that can be used to specify the HSRP group. In our case, it's group 10, so if we have 3 hexadecimal digits to represent group 10 in decimal, well in hex that's going to be 00A. And we'll conclude this video now by reminding you of the 3 commands we issued to do verification and or troubleshooting of HSRP. We could do a show standby brief command, which gave us a great overview of our HSRP configuration. If we want more detailed information like we see here that gives us virtual MAC address information and tracking information, we could give the show standby command without saying brief. And we also did a debug. We did a debug standby terse command. It turned on the debugging of HSRP errors, events, and packets. Please remember, if you turn on a debug command, be sure to turn it off after you no longer need it, because packets that appear in the debug output are being handled by the router's processor. And depending on the number of packets, that could really put a processor impact on the router. And we showed you how to turn off debugging by doing a U space all, which is short for undebug all. And combined with the previous video, we've now seen how to configure and verify HSRP operation.